Bismillahirrahmanirrahim. Now we're going to continue our statics revision. Equilibrium of a body on a rough inclined plane. You have this rough inclined plane and inclination angle of this plane with horizontal is theta. We have also this body placed on this rough and this body is under the action of its weight only. Okay, then here its weight is acting vertically downwards like this, and if we assume in the x direction, in this direction parallel to this inclined plane, and we have y direction parallel to it, then we have to resolve this weight in these two orthogonal direction. Okay, here we have this component w cosine theta. Okay, as we have here this plus this equals 90, and we have this one and this one equals 90, then this angle is theta as well. Then we have w, this direction we have the component of the weight w cosine theta, and this direction we have w sine theta. Okay, also we have this normal reaction force of this inclined plane to the body, okay, in this direction, in y direction n. Okay, then here the expected motion direction if the body is affected or acted by its weight only in this direction, the word is the inclined plane. Okay, then in opposite direction to the expected motion direction, in this direction we have this friction force F. Okay, F here. Here if as we said the body is body is under its weight only. We don't have any external acting forces acting upon this body. Then in this case we have mu s equals 10 lambda, where lambda is the friction angle between this body and the rough inclined plane. Okay, and here we have three cases of this or for this body. Okay, according to the comparison between theta and lambda. Theta is the inclination angle of this rough inclined plane to horizontal, and lambda is the angle of friction between this body and this rough inclined plane. Okay, if theta is less than lambda, okay, the body is at rest and not about to move or not moving. Okay, if theta equals lambda, then the body is about to move. Okay, if theta is greater than lambda, then the body is moving already, is moving on this rough horizontal plane, and the direction of motion downward is plane as it's acted only by its weight. Okay, then if we need this first case, if we have an external force, okay, acting upon this body, for example we have this inclined plane, okay, and inclination angle to horizontal is theta, and we have this body also, as we said before, we have here w cosine theta. This is the component of the weight in this direction, and we have another component w sine theta, the component of the weight in the other direction, as we assume this direction is x and this direction is y. Also we have here this normal reaction of the inclined plane on this body. Okay, and here if we assume there is an external force acting parallel to the inclined plane in this direction, for example P. Okay, first we need to identify the expected motion direction of this body. Here we have to compare between the component in this direction and component of forces acting upon this on this body in this direction. Okay, in this case if we convert P and W sine theta, okay, if P is greater than W sine theta, then the expected motion direction is upwards the inclined plane in this direction. Then in opposite direction, in this direction we have here F friction force, and if the body is in equilibrium or the body is about to move, then F is this friction force equals limiting friction force Fs, and Fs equals mu s times n if the body is about to move. Okay, here the direction of this friction force opposite to the expected motion direction, which is in the upward direction of this inclined plane, as we have P is greater than W sine theta. Okay, in other situation, if P is less than W sine theta, okay, then the expected motion direction in this case will be downward the plane like this. Okay, then friction force will be in this direction. Okay, in the direction of external acting forces P. Here we have friction force. Okay, as the expected motion direction downward, then the generated friction force in this direction. Okay, so we can sketch these two condition or two situation. We have this one. Okay, here we have here theta, we have W cosine theta, we have here W sine theta. Okay, we have here force B, external force B, and we have here normal reaction. Okay, also we have the same situation here like this. Okay, here we have theta, we have here this body, I have this component of its weight W cosine theta, and we have here the same acting force P. Here we have N. Also we have here W sine theta, the component of the weight in this direction. Okay, as we need to identify okay, direction of motion, expected motion direction of motion. Okay, here we have to compare between B, okay, B and W sine theta. We have to compare B and W sine theta, and as we said before, P is all forces or force components acting in this direction. Okay, here if P is greater than W sine theta, B is greater than W sine theta, then the expected motion direction in this direction. Okay, and here in opposite direction we have here F force. Okay, if here the then motion, expected motion, okay, direction is upward the plane. Okay, then in this direction downward the plane we have F, and if the body is about to move, okay, then we have here F equals Fs. Okay, if we apply the equilibrium equation here, equilibrium equations, we have two equations, summation of x equals 0 and summation of y equals 0. Here we assume that x is parallel to this inclined plane and y is perpendicular to it here also. Okay, so for x equals 0 we have here p in positive direction of x, then we have p, okay, minus f minus w sine theta, or the component of forces in this direction equals the component of forces of this direction. Then we have here negative friction force F, and if the body is about to move, F is Fs. Okay, and we have here minus w sine theta, and this is equal 0. Okay, this is equation number 1. Question number 2, summation of forces in y direction equals 0. Considering vertical upwards here is positive, then we have n minus w cosine theta equals 0. This is second equilibrium equation. Okay, this is in this case. If we repeat for this case, if B is less than W sine theta, then the expected motion direction in this direction. Okay, in opposite direction here we have this friction force, this force F, and this is equals Fs in case if the body is about to move. Okay, Fs equals mu s times n. Okay, where n equals W cosine theta from this second equilibrium equation. Here the expected motion direction is downward the plane. Okay, then in opposite direction here, in direction of external acting force B, we have this friction force. Here If equals fs equals mu s times n in case of the body is about to move and the expected motion direction in these downwards directions. Then equations of equilibrium. Okay, here we have summation of x equals 0, summation of y equals 0 also. For this component or for this direction, okay, parallel to this inclined plane and y is perpendicular to it. Then we have here b plus f, okay, equals this component w sine theta or minus w sine theta equals 0. Okay, and this is equation number 1 in this situation, and we have also n minus w cosine theta equals 0 as n in positive direction of y and w cosine theta in negative direction of y, and this is second equation in this situation. Okay, also steps of solution. Okay, steps of solution the same as in horizontal plane. Okay, if we have this inclined plane and this body placed on this inclined plane, first we have to identify x and y direction. In this kind of problem, it's preferable to select this or assume this direction is x and this direction is y. Okay, number 2, you have to identify all forces, okay, forces acting upon this body. Okay, we have here also, we have here many forces. For example, this component of weight w cosine theta, and here we have w sine theta. We have external forces, for example, in this direction or this direction or this direction. Here, for example, b. We have here normal reaction force. Okay, then number 3, you have to identify expected motion direction. Okay, expected motion direction by comparing the component of forces in this direction with the component acting upon this body in this direction. Which one is greater than the expected motion direction in its direction? Okay, then after that you have to identify friction force, which in opposite direction to the expected motion direction. Okay, for example, if for example b is greater than w sine theta, its expected motion direction is this direction. Here we have here f friction force in this opposite direction to the expected motion direction, which is in the direction of w sine theta downward is the inclined plane. Okay, then finally we have to apply equations of equilibrium. Okay, we have summation of x equals 0, summation of y equals 0. X here is the direction parallel to this inclined plane, y is perpendicular direction to this inclined plane. We have this example: a body of weight 30 Newton is placed on a rough inclined plane and it's about to slide when the plane is inclined at 30 degrees to horizontal. If the inclination angle of the plane is to horizontal is raised to be 60, find the least force P, keep the body in equilibrium and acting parallel to the plane upwards, and find the greatest force in the same direction and keep the body in equilibrium. Okay, we have here two situations. When theta equals 30, theta is the inclination angle of this rough inclined plane to horizontal. Here we have this situation. We have here theta equals 30 and we have this this body placed on this rough horizontal plane. Here the body is about to slide downwards under the action of its weight only. Then as we said here in this case theta equals lambda equals 30 degrees, then the static friction coefficient between this body and this rough inclined plane mu s equals 10 theta. Okay, 10 lambda. When lambda equals theta, then we have here mu s equals 10 theta as well. Then this equals 10 30, this is equals 1 over root 3. Okay, then mu s equals 1 over root 3. This is from first situation we have. Okay, second one, if theta is raised to be 60 degrees and we still have mu s equals 1 over root 3. Okay, then it's required to find the least force P working parallel on this body parallel to the inclined plane upwards and keep the body in equilibrium. And we need also to find the maximum value of this force. Okay, here we have two situations. Okay, as we have here this body here, for example, this here we have theta. Okay, theta in this case is 60. Okay, and we have also this one theta, this body here. Okay, and we have the same body here. Okay, now we have here B acting in this direction, and we have also B acting in this direction. Okay, in this one the body is in equilibrium. We need to find B minimum. Okay, here we need to find B maximum. Okay, now we have to apply the steps of solution of this kind of problems. Here we have to find x and y, in this direction x and this direction y. Okay, the forces acting on this body, we have this external force, we have this weight component W cosine theta, and we have here W sine theta. Okay, we have this normal reaction. Okay, in this situation we have also here the same forces in W cosine theta and W sine theta. Okay, then secondly we have to find the expected motion direction. Here you have to know if we need to find B minimum. Minimum means that the body is about to slide downwards or to move downwards. Okay, since expected motion direction is in this direction, this is mean if we need to find B minimum. Okay, the expected motion direction here's the expected motion direction, as we need to find B maximum is upwards here in this direction. This is the expected motion direction. Okay, then if we need to find minimum, then the expected motion direction is downwards the plane. B maximum, the expected motion direction of this body is upwards the plane. Okay, now we need to find the friction force. In this case, body is about to move. Then we have here F equals Fs equals mu s times n. Also have F equals Fs equals mu s times n, as the body is about to move in both cases. Okay, then the direction of Fs here in this direction, Fs in B minimum, as it's in opposite direction to the expected motion direction. Okay, here P Fs direction of Fs in direction of W sine theta downward the plane, as it's in opposite direction to the expected motion direction. Okay, now we need to resolve all forces in x and y direction, and we already all forces are resolved as we should. Okay, then we have to apply final or last step is to apply the equation of equilibrium as the body is about to move. Then we have equation also of equilibrium. Okay, here we have summation of x equals 0, summation of y equals 0. Summation of x here we have B minimum plus Fs equals W sine theta. This is equation number 1. And we have n equals W cosine theta, and this is equation number 2. Okay, now we can substitute from this one in this one and substitute by Fs equals mu s times n. Okay, and we have mu s here 1 over root 3, here we have times n. Then P minimum from equation number 1 equals W sine theta minus Fs is mu s times n. Okay, then we have here W k sine theta minus mu s is 1 over 3 times n is W cosine theta. Okay, here we have W is 30, sine theta is 60, then we have sine 60 minus 1 over root 3, W is 30, cosine 60. Okay, then we can find B minimum equals 10 root 3 Newton, and this is required number 1. Okay, We can apply or repeat these steps here when B is maximum, as the expected motion direction is in upwards direction, okay, and F is limiting, friction force is limiting friction force equals mu sin time n. Equation of equilibrium, summation of x equals 0, summation of y equals 0. For this equation, we have here B maximum, okay, equals Fs plus W sine theta, okay. This is equation number 3, and we have n still equals or W cosine theta. This is equation number 4. Then we can find B maximum equals Fs mu s, as we have mu s 1 over root 3 times n. N is W cosine theta plus W sine theta. Here we have theta still 60. Then we have 1 over 3. W is 30 cosine 60 plus 30 sine 60. Then we can find here B maximum equals 20 root 3 Newton, and this is required.